Hello, 8th graders. Today we are tasked with the job of calculating the surface area of a triangular prism. Thanks, Mathletics. Good grammar there. That should be a triangular prism or the triangular prism, but that's okay. We can deal. No big trouble, no big problem there. So the key here is to separate area from volume. We are calculating the area, which is simply the ground or the space covered by the outside of this figure. We're not concerned with the inside at all. And so my strategy here is going to be to sort of take this on one side at a time. So let's start with something that maybe you're familiar with, maybe you can recall, hopefully. And if not, I'll bring it back to mind. But let's start with that triangle there. So the formula for area of a triangle is base times... let's actually use the dot to represent multiplication. We should be doing that here. Base times height divided by 2, right? So we've got a base of 6. And of course, this only applies to triangles with a right angle here, which is designated by that symbol. And let's go, base is 6, height is 8. Divide that by 2. And what do we get? We get 24. Now I'm going to write 24 here on that panel, and at the end we're going to express this as centimeters squared, although Mathletics has sort of taken that part out of it for us. They've typed that in, so all we need is the number. Now this end panel down here is going to be the exact same dimensions, so we can put a 24 there as well. So always keep in mind you've got two ends to this figure. All right, and then what do we have left? We have the 3 rectangles, and sadly all 3 of these rectangles are going to be different dimensions. So we'll start with the back panel, and I will trace the outlines of this panel here for you. That line right there is going to be 8, and I know that because this line down here, whoops, this line down here, I want my pen. Where's my pen? Stitch. Oh, there we go. A little bit of a technical problem there. That line is 8. So 8 and 8. And when it comes to rectangles, we need length times width, right? So we also need the length. And we're going to trace that here. Okay. So I'm going to write over here lengths. Whoops. And again, I want to use the dot to represent multiplication. Length times width. So we've got... Whoa, that was a terrible line. Let's redo that one. Oh. Come on, stay straight for me. Better. Okay, so we've got a length of... Can you see how long it is? It is 30 because it's adjacent to this line here, same exact length. So we've got 30. Sorry, adjacent is not the right word. It should be parallel. All right, 30 by 8. And I can do some mental math there and say 3 times 8 is 24. Add that 0, and I've got 240. So I'm going to write that right here on the middle of this panel. And again, it's a little tricky because we got some see-through panel action happening. But now let's focus on, let's use green to focus on this bottom panel over here. That bottom panel. So we've got a length situation of 30 again, but this line is not going to be 8, it's 6. So we have a figure that is 6 by 30. All right, so a little different. This one is 30 by 6. It would be nice if all the 3 rectangles were the same dimensions, but they're not, sadly. Okay, 30 by 6. So that gives us 180. 180. Okay, we're almost there. We've got one more rectangle. I wonder if I could use the rectangle tool. What? Could I do that? Okay, playing around here. Let's use orange. And then can I rotate that at all? No. Okay. So we'll just draw it out. No problem, no big deal. Now we have to kind of pull some, oh, I forgot my lovely arrow. This is going to get a bit messy here, but let's throw an orange. Where can I put it? I don't know where to put it here. There? I don't know. Let's keep drawing. You can follow the orange to see the panel I'm talking about. Okay, that length and that width. Okay. All right. Messy, but it works. So now we've got a shape that is 30 by 10. And that doesn't surprise us, by the way, that width is going to be the longest, because if we look back at this triangle, if you think back to the Pythagorean theorem, we've got our A side, our B side, and then the 10 is the C side. So it should be the longest of these three sides. So of course that equals 300. Now where should I write that? I'll say 300 right here. Okay. So we've got 5 different panels. Now it's easy to overlook the other 24, so I'm going to just write that there. So we need to add up these. We'll use a different color for the circle. Let's use black. I don't know. We're going to add 24 plus 24 plus 240 plus 180. Oops. And we're going to add these to these, and then we should have a final answer showing area. So let's bring up my handy dandy calculator here. Oops. Yeah, sure. Let's put me in the corner there. And I've got 24 plus 24 plus 240 plus 180 plus 300 equals 768. I actually can't write it there. I have to go back to that. Oh, okay. Well, I believe 768 would be the answer there.